thanks for joining. Today's webcast will be about building real-time pipelines with Kafka, Spark, and MemSQL, and will also include a live demo. The webcast will be led by Stephen Kamina, who is product manager at MemSQL, and we also have our technical marketing lead, Connor Doherty, who'll be running through some Spark stuff and the demo. And if you have any questions during the webcast, please enter them through the GoToWebinar question panel, or you can send us a tweet at MemSQL. And the presentation will be about 20 minutes, and we'll field questions for 10 minutes or so after. And with that, I'll hand it over to Stephen.
Excellent. Thank you, Kevin, and welcome to this MemSQL webcast. As Kevin said, in this webcast, we'll be talking about MemSQL as a product, but we'll be spending most of the time talking about the MemSQL and Spark integration. So first, a little bit about MemSQL as a company. MemSQL we were part of the 2011 Y Combinator class. We have currently experienced leadership from Facebook, from SQL Server, from Oracle, from Fusion.io, and several other companies. The company really was built around solving that enterprise gap of having real-time transactions on big data workloads. As such, MemSQL is built as an in-memory distributed relational database, which I'll talk about in a bit. MemSQL has top-tier investors, such as Accel, the company that founded Cloudera, and Coastal Ventures. And so to date, we have about $50 million in funding. A little bit about MemSQL as a product. Let's break that down a bit. MemSQL is the real-time database for transactions and analytics. We say real-time because most of our processing and data storage happens in memory, so it's very, very fast. We are distributed, allowing you to scale out across commodity hardware, thus lowering cost, and also allowing you to scale storage and computation across nodes. And the third big piece is we are relational, so we are SQL. It's in the name of the product and the company. So we believe in the viability of SQL, and the primary way to interface with MemSQL is through the SQL interface. MemSQL is a piece of software that can be run on virtually any medium. It can be run on your data center, on bare metal machines, it can be run on VMs, it can be run on containers, on-prem or in the cloud. A little bit about where MemSQL is currently applied to. MemSQL can be applied into many markets, applications, and solutions. Just looking here at this slide, some examples of markets. The common theme for all the markets are really where data is collected and insight is required on that data. So examples are ad tech, financial services, energy, media, etc. For applications, the common theme is real-time analytics, which could include risk management and personalization, which are big for ad tech, portfolio tracking, which is in finance, and monitoring and detection, which is for monitoring and detecting problems in your infrastructure. For solutions, examples of solutions for MemSQL is currently applied are IoT or Internet of Things solutions, especially since we have geospatial and sensor and location data everywhere. Also real-time data pipelines, which we will be discussing more deeply later in this presentation, and operationalizing Spark, which again we will be talking about later. Our current release of MemSQL, released in May, is MemSQL 4. And this slide talks a little bit about the evolution of MemSQL through the years. So when we first launched in 2012, it was a single box relational database, still in memory, so still very fast, but running on a single node. MemSQL 2, we introduced the concept of being distributed, being able to scale out MemSQL across commodity hardware, as well as having JSON data and relational data in the database. In MemSQL 3, we introduced the MemSQL column store, which is a disk-based column store. So now we have an in-memory row store and a disk-based column store. We also introduced the concept of cross-data center replication and multi-statement transactions. And now in May, in MemSQL 4, we've introduced several features, the biggest of which is our Community Edition, a free forever version of the product. We've also introduced a bunch of features around geospatial, connectors, and a new tool for deploying and monitoring MemSQL. Before we dive into some of the features, let's talk a little bit about what were some of the critical market drivers that we saw that prompted us to build MemSQL 4 this way. The first piece is about more enterprises really seeking real-time operations. And what this means is companies want to reduce analytic latency, which means but when the data comes in until the time you can do analysis on the data. And we believe and we know that in-memory makes this possible. A second big market driver is HTAP, which stands for Hybrid Transactional and Analytical Processing. This is a term coined by Gartner. You can download the paper actually on our website. And basically this means companies are looking to do transactions and analytics as part of the same workflow. And the third big market driver that we see is enterprises are constantly looking for ways to reduce cost by scaling out across nodes, which is a feature that MemSQL delivers. Speaking of the Community Edition, which I mentioned earlier, the biggest announcement for us in MemSQL 4 back in May was this Community Edition. Community Edition is a free forever version of MemSQL that we hope will allow everyone, all developers, to try and play around with MemSQL. It has unlimited capacity and unlimited scale and all the transactional and analytical features you need in MemSQL. Enterprise Edition, we continue to offer a free 30-day trial, and we continue to encourage prospects and customers to try that. It features 24/7 support, as well as certain enterprise-only features like high availability, cluster replication, user controls, and features around security. Before we dive into some of the features, which I'll talk about really quickly, the guiding principles for MemSQL 4 were these three. The first piece was database innovation, so continuing to deliver innovations on database technologies. The second big piece was integrating with the rest of the ecosystem, which includes Spark. And the third piece was simplifying the operations and deployment and management of MemSQL, which we delivered through the new version of MemSQL Ops. First piece is about database innovation. The big feature we introduced, or one of the big features, was MemSQL Geospatial. So we believe that it's a critical time to be releasing a feature like Geospatial because location and sensor data is everywhere. And in MemSQL 4, Geospatial is a native data type in MemSQL. So you can now define points, lines, polygons, filters, and measurement functions around geospatial data. Also in MemSQL 4, we've enhanced our column store. As you may or may not know, MemSQL has a in-memory based row store and a disk-based column store. So you put your very hot, mission-critical data in the row store, and then you have your historical data in the column store. In MemSQL 4, the column store storage, which is disk, is provided for free. Of course, MemSQL 4, the next version, wouldn't be complete without extra SQL features and enterprise capabilities. This slide could actually be an entire presentation, but we've distilled it into 4 points. First piece is we have an enhanced MemSQL query execution engine, which now includes a mechanism for fully distributed joins, which is a very tough problem to solve for a database, for a relational database. The second piece is we have a cost-based optimizer that we've enhanced that can do cost-based heuristics across distributed nodes. We also have several other features, robustness features around when nodes fail and how the cluster cell heals and responds to failure scenarios. We have a security feature around SSL encryption, and we've increased our SQL surface area with more SQL functionality. A little bit now about the product ecosystem, and then I'll turn it over to Connor. MemSQL, as you can see here in the middle of this slide, integrates with a lot of different applications in the market. One big decision that we, MemSQL, made as a company was to be compatible with the MySQL Y protocol. So MySQL Y protocol. And the beauty of this is that all your applications that connect into or through a MySQL database, can also connect to a MemSQL database. We use the same client driver as MySQL. So this opens the door for BI dashboards such as Tableau, for all your in-memory applications that have transactions and analytics, and everything that connects, all these IDEs, all these developer tools that connect into MySQL, connect into MemSQL. Of course, the standard ways of connecting into relational databases such as ODBC, JDBC, and .NET connectors are also possible. It's also possible to do so with MemSQL. We also have a MemSQL loader that allows us to load data from Amazon S3 buckets and HDFS, and can be deployed across several cloud providers, such as Azure, Amazon AWS, and Mesosphere. Finally, in this slide, MemSQL plays very well with Spark, but instead of me talking about it, I'll turn it over to Connor for the Spark portion of this presentation. Connor?
Great, thanks, Stephen. So at the core of the integration between MemSQL and Spark is the MemSQL Spark connector, which we actually released open source last winter. What you're going to see today is a demonstration of, it's kind of a sneak peek on some of the added functionality that will be in the next MemSQL release around integration between MemSQL and Spark. So the focus and the reason why we're interested in using MemSQL and Spark together is the utility of Spark as a very versatile data integration platform. So you can use it for stream processing, as we're going to be demonstrating today using Spark streaming, but the thing is that Spark is just a general purpose distributed data processing framework, so you can use it for offline ETL as well. The other nice thing is because the tool has gotten so popular, there are already connectors for all kinds of different serialization formats, so like Parquet, Avro, Thrift, protocol buffers, and when you use Spark, you can use these connectors and use these libraries that the community has developed. So the demonstration that I'm going to be showing you today is a real-time data pipeline that consists of Apache Kafka, sending data to Spark, sending data to MemSQL. So the demo that I'm running is running on Microsoft Azure. It's kind of a little toy setup. It's only running on 4 nodes. But the great thing about using each of these tools and architecting the pipeline around these types of tools is that they're all distributed systems and scale out horizontally on commodity hardware. So while this demonstration is just on a little toy cluster, it's actually using the exact same tools that MemSQL users like Pinterest are doing. And if you want to learn more about how Pinterest is using Kafka, Spark, and MemSQL, you can check it out on our blog and on our website. So the reason that we're using Kafka and Spark in this example is that they provide solutions to very common challenges. So the notion of a message queue is having a unified place where lots of different applications or users can read messages off of. Another reason, like I mentioned before, is that they're both distributed. So you can scale out on commodity hardware when you need to add capacity. They're also both fault tolerant, which means that if you lose nodes, you can regain the state that the system was in prior to the node failure. And Kafka and Spark in particular, provide really nice abstractions for dealing with data, especially in this kind of pipeline scenario. So the example that I'm going to be showing you is a demo we came up with that we call MemCity. It's a city of the future where all devices are connected and they are reporting their power consumption to this power monitoring system. So the way that it starts out is there are houses which each have some devices associated with them, and at some interval of time, the devices kind of wake up and publish the amount of power that they've consumed. So you can see this in the top step up here. This is the record coming in. So it looks like a timestamp, a house ID, a device ID, and some amount of power consumed. But you wouldn't know that just from looking at this record. It's very minimal at this point. We're going to be using Spark for enrichment later. But in order to publish it to Kafka, we first serialize the record. So it's a binary file. You do this before you send it over the wire for compression. So the next step is after it gets published to Kafka, it gets added to the message queue. So in particular to our MemCity Kafka topic. Spark is polling Kafka for new messages. So it's constantly it's constantly checking the MemCity Kafka topic and seeing if there are new messages. And when there's a new message, it reads it off of this topic. The first thing it does is deserialize the record so that we can write it into MemSQL. Another use for Spark streaming is you can do enrichment. So like I showed you before, when the record comes in, there's not a whole lot of information. There's pretty much just a timestamp and then kind of the bare bones of the event. But using Spark Streaming, you can do some pre-processing of the data. Do something like a lookup where you say, okay, here's this house ID. Now I'm going to go check this lookup table and see which zip code this house corresponds to. So you can add these into the records and do this pre-processing so that as soon as the data lands in MemSQL, it's already ready to be queried in by a business analyst, for example. So the final step of the pipeline is saving the data to MemSQL. So this is using our MemSQL Spark connector, which provides this abstraction of MemSQL RDD, which comes with this nice method, save to MemSQL. So you have your MemSQL RDD that you've prepared you've told Spark how to prepare this MemSQL RDD, and then it's just a single command to save it into MemSQL, and it writes it into this table. The final step is the visualization. So in this example, in the original version of this demo, we were using Tableau for doing the visualization. So MemSQL is actually doing the heavy lifting here in terms of doing both the ingest of the real-time data and also computing the queries to create these visualizations. In this example, today I'm actually going to be showing you the visualization using another BI tool called Zoom Data. I just started using it yesterday. I wanted to learn how to use it. It's a very intuitive interface, so kudos to them. I figured it out quickly. So let's get into the demo now. So like I said, this is running on Microsoft Azure. It's running on 4 nodes. So the first thing that I'm going to do is we're going to be writing into this table device events. So this is what the table looks like. We're writing a timestamp, a house ID, a device ID, the amount of power that was used, and the zip code. And you can see right now that this table is currently empty. So I'm going to go ahead and turn on the demonstration. So the first thing that we're going to do is turn on the data generator, which is going to be writing the data into Kafka. So just to verify that there is some data coming into Kafka, I'm going to run this script, which basically just every message that comes into the MemSQL topic, it just writes it to standard out so we can see what's coming through. And right now it's nothing. So let's go over, and I'm going to turn on the data generator, which we lovingly call the Kafka spammer. And now when we go back to that window, we're basically just spitting everything that comes into this Kafka topic. And you see that it's just total gibberish. I stopped it there. Maybe you couldn't even see it was total gibberish, but now you can, now that it's stopped. This is because, like I said before, the messages that are getting written into Kafka have already been serialized. So this is just a binary file. So we need to turn on Spark to accept this data from Kafka and write it into MemSQL. So I'm going to start the Spark streaming job, which is going to accomplish this. So this is kind of a long command, but really all that it's doing here is it's running Spark submit, which is the program that you use to submit your job to Spark, and it's submitting this class MemCity annotator, which is it's reading the data off of Kafka, deserializing it and enriching it like I showed you in the slides. So now we can look at our Spark master, and when we refresh here, we can see that the Spark job is running, and we can actually look at each partition is currently processing this data and writing it into MemSQL. So let's just go back and look at MemSQL here. And so we can now see that we've already stuck in, over 1 million events into this device events table, and this number is just going to keep going up. So remember, the data is flowing all the way through this real-time data pipeline. It's starting with our generator, it's getting published to Kafka. Spark streaming is reading off of the MemCity Kafka topic and writing it into MemSQL. And this is all happening in real time. So now, the really nice thing is, because MemSQL has a SQL interface, you can use pretty much whatever business intelligence or data visualization tool that you want, because they all speak SQL. And because it's updating in real time, the charts that you create are going to have access to the most recent data. So here's an example chart that They have good security too, I guess. So here's a chart that I put together earlier, reading off of this, off of the device events table. So this is a very standard type of chart that a business analyst might make. It's just doing slicing and dicing. It's taking all of the total power usage, which is on the x-axis, and breaking it out by device type. So we can see that MemCity is truly a city of the future, and everyone apparently has a waterbed, and the most power is being consumed by waterbed heaters. So I can go back and I can show you another chart that I created as well. So now instead of breaking it out by device type, we're actually breaking it out by zip code and then device type after that. So we can see that the zip code that's consuming the most power is 90029, and within that we can see that there are a bunch of people with waterbeds. They have a lot of night lights, I guess, as well. And this is all on the live data that's flowing into MemSQL in this streaming way. So that's the end of the demonstration. And it's time for questions.
Great. So now's a great time to put in some questions through the GoToWebinar question panel. We have a few that came in through the duration of the webcast, one is, how is MemSQL different than Spark SQL?
I can take that one. So this is a fairly common question that I've heard at trade shows, and the biggest difference is that Spark is not a database, and it's not designed to be. This is not a flaw per se. It's meant to be a data processing framework, so it's not a stateful system like MemSQL. So in addition, there's no concept of an insert or an update or delete. Spark treats data as immutable. So there's no way to do transaction processing, for instance. Those are the biggest differences. So in terms of building an application where you need to be analyzing changing data, that's when it's really useful to use a system like MemSQL, which in addition to being a query execution engine, is also a stateful database.
Great. So we got another question here. Is MemSQL a plugin for MySQL, or is it a database itself?
I can take that because that's simple. It's a database itself. So MemSQL does not need MySQL to function. MemSQL is its own relational database. So the only tie point or the only relationship between MemSQL and MySQL is that the client driver that you use to connect to MySQL, you can also use the same driver to connect to MemSQL. But MemSQL in itself is a standalone, relational, in-memory, distributed database.
Great, thanks, Stephen. So another question about Spark usage. So right now I'm using Cassandra with Spark. How is MemSQL different, and how does it compare?
Sure. So I would say that there are two main differences between MemSQL and Cassandra. One of them is that Cassandra uses disk as the primary storage medium, whereas MemSQL is a memory optimized system. So our row store does store data purely in memory. So you'll get a little bit, you'll have faster reads and writes for data stored in memory. Another big difference is that Cassandra is a key value store. It's not a relational database. So there's no, in their query language, there's no concept of a join, for instance. There's no way to bring information together from multiple tables. And actually, in our demo, I can show you. So the way that I have this demo set up, I have three tables. I have the device events table, which I showed you earlier, and then I have this, which in business in BI terminology, this device list table is a dimension table. So it's very small. It just has the list of device IDs and the names of the devices. And the way that I'm populating these Zoom data charts is actually with a view, which is the devices with names view. And you can see I have this name column, which I am creating by pulling it in, by doing a join between the device events table and the device lists table, which creates this one single unified view, so that when I am creating these charts in Zoom data, we have the information, like this is a waterbed heater. So for instance, instead of having something like that, I could just do device type ID, and it'll just show you the number for the device as opposed to actually having the name there. So this is just an example of a simple thing that you can do in MemSQL that you wouldn't be able to do in a system like Cassandra.
Great, thanks, Hunter. I have a question about Community Edition, which is, can a cluster be set up and done with Community Edition?
I can take that. Answer is yes. MemSQL is designed to be a database cluster, whether that's community or enterprise. So in fact, if you download and install MemSQL, the only option to install MemSQL on a single host, on a single machine, is to do what we kind of call a cluster in a box, which is an aggregator, like 2 MemSQL nodes residing in the same machine. So yes, it needs to be clustered. One thing, though, about community and enterprise is Enterprise Edition is what allows you to configure high availability. And what that means is with Enterprise, you get a redundant copy or a secondary copy, a slave copy of every data point, or of every data, all pieces of your data with Enterprise. And that is not available in Community.
I'm actually running this demo on MemSQL Community Edition.
I have a question, is MemSQL ACID compliant?
Yeah, I can take that. Short answer is yes. The biggest question we get, so MemSQL is a relational database, and as such, there are ACID guarantees the databases need to stick by. I think the biggest question that we typically get is the D, the durability piece of ACID. So let me talk a little bit about that. Because we are an in-memory database, lots of people tend to ask, how does persistence work? And typically, that's part of the ACID conversations we have. MemSQL does provide durability, and it does it in several ways. So the first piece is, in every MemSQL node, we keep a transaction log and a database snapshot of the in-memory database and persist that to disk. So that means at any point in time, we have a snapshot, which is a full sort of snapshot or image of the database in memory, and transaction logs persisted to disk. In the event of an ungraceful shutdown, we simply put the snapshot back into memory upon restart and replay the transaction log. So we get you back to a transactionally consistent point in your database. Secondarily, we have high availability mechanisms, which I described, currently are enterprise only, that allow you to create redundant copies of your data. We also have mechanisms for data center replication and database replication.
Great. We have just one last question here. It looks like, so this person says they're an InterSystems partner, which uses NoSQL, and we want to use MemSQL for healthcare scenarios. Can you work with NoSQL?
I can take that one. So, yeah, so there's not really a consensus definition of NoSQL, but the way that I think about it is twofold. Is one, a lot of people associate it with scale out, which MemSQL can do. It's a distributed system, just like any of the NoSQL databases. The other thing is a lack of schema. So you use either a document store or a key value store. So MemSQL does have a schema, a relational schema, but we incorporate a lot of the features of a NoSQL style database in 2 ways. So number one, we support JSON as a column type. So that allows you to create these document style storage schemas within a relational column. And then if you want to pull data out of one of those columns, you can actually create a computed column and it will index it just like any other column in a MemSQL schema. Another sort of flexibility related feature is MemSQL supports online alter tables. So a lot of people associate making schema changes with being very difficult. You need to back up and turn your system off. This isn't the case with MemSQL. You can make changes to the schema. You can add and remove columns, add and remove indexes. You can do all of this with the cluster online, even while it's running a workload. So I hope that answers your question in terms of how we can work. MemSQL encompasses a lot of these NoSQL style features but then you get the added benefits of the relational model and the query surface area that comes with that.
Great, thanks. We'll end it as far as questions go with that. There are some other questions that we'll follow up with offline. And the webcast is being recorded today, so we'll also follow up with a recording of the webcast. And thanks to Connor and Stephen for presenting today. And I want to encourage everyone, if you haven't already, to download MemSQL and give it a try at memsql.com/download. And if you have any other questions, you can send us a tweet or send us an email at info@memsql.com. Thanks everyone for joining, and have a good one.